In this video, I would like us to look at some electromagnetic induction demos. So what we have here is a variable power supply, this thing over here. It is plugged into the wall socket. Actually, it's plugged into a power strip that's plugged into the wall socket so that I can control the on-off switch from the strip so I can stay out of this picture. So the special thing about this variable power supply is that there's a dial here, and I can set it at whatever value I want for the demo to work. Now into this variable power supply, we have this other device plugged in, and when I turn this on, current will flow through this device. Now what this device is an electromagnet. So this thing here is a solenoid, a big long solenoid, and inside the solenoid there is an iron core, we call it. It's basically a whole bunch of rods in a plastic tubing. So let's look at the demo real quick. So when the power is off, you see that the iron core is just not connected to anything, it just comes out. And then when I turn the power on, that was my daughter helping me with a demo. She tried to pull the iron core out and she couldn't do it. So let's watch this again. Pay attention. So no power right now. You can see the iron core. Now we turn it on and you see that the iron core doesn't want to come out anymore. It is actually so hard to pull it out that it actually lifts this entire thing up. And this thing is very heavy. It's very heavy metal here. So what happened? Well, when there was no current going through the solenoid, there was no magnetic field in there, and the iron core came out very easily. Once we turned the current on, current started flowing through here, and we know that a current going through a solenoid produces a magnetic field. So that means that this iron core was in a magnetic field. When my daughter tried to pull this out so that it would exit the magnetic field, it reacted to it. It didn't want to do that, so it basically hung on to the solenoid. It just wouldn't come out. The similarity to something that we've learned before is this. Remember the motional EMF. So here we had a bar across this U-shaped wire, and it was in a magnetic field. We tried to pull it to the right, and as a result of that, there was a force pulling it to the left. So there was a separation of charges, and then charges started flowing in this direction, forming a current through there. So then this force was due to the current times L times the magnetic field, and by the right-hand rule, the force pulled back. So whatever we tried to do to it, it opposed that change. Same thing in the demo. No current, this comes out. As soon as we put current through the solenoid, it produces a magnetic field that this rod does not want to leave. All right, let's look at another demo. Same setup. Let's see what happens. Aha. I turn on the power supply and that ring jumps. So what do we have here? Let's start it one more time. Let me pause it. So I have two rings. This ring is complete. It's a complete circuit. This ring has a slit in it. So when we turn the power on, this ring will all of a sudden be in a magnetic field caused by the electromagnet. That ring doesn't like this change. It doesn't like the sudden magnetic flux through it. So it will induce a current that produces a magnetic field that opposes the change in the magnetic flux, which is why this current is going to flow through here, creating a magnetic field that opposes the magnetic field that created it, and that's why there's a separation. It's like North Pole versus North Pole. They don't want to be close together. Now the problem with the second ring here is that there's a slit in it. There is no current flowing through it because it's a broken circuit. Let's look at it one more time. Actually, this is the end of the first video. So one more time now. All right, another demo. So again, we have our solenoid here, our electromagnet, and my daughter is showing you a light bulb, 12-volt light bulb connected to a whole bunch of turns of wire. We place it around the solenoid that's turned on, and the light was lit. Now here is another one, and that's what happens. So when we had only a few turns of wire, a current started flowing through the coil of wire due to the magnetic field that it was placed in, and the light came on, but only a little bit. When we had more turns of wire, the same type of light bulb, a 12-volt light bulb, is going to be much brighter because of the larger number of turns of wire. So this is an example of how a transformer works. In this example, the solenoid would be the primary. So this is what provided the magnetic field, and then each one of the coils would be the secondary. And remember that the voltage to the secondary divided by the voltage to the primary is number of turns through the secondary divided by the number of turns in the primary. So the more turns we have, the more voltage we have as well. So that's why when we only have a few turns of wire, the light is not going to be as bright as it is when we have a lot more turns of wire. And there it is.